So we could just make a table by substitution, but that would take a while. What I would advise you to do is to try to do a sketch based on some of the critical points that we know. Like what form is that quadratic equation in right now? The one they gave us. We learned three forms. What form is that one in? Since you don't see any parentheses. Yeah, it is in standard form. So from standard form, what critical point is easy to get from standard form? Yeah, the y-intercept. What's the y-intercept going to be? Say it again? Yeah, 0, 0. Because the c is 0. If I wanted to get the vertex, okay, I would need to do negative b over 2a. So right now, a is negative 1, b is 8, and c is 0. That's why it's going to be at 0, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right here. And then we'll figure out what to count by going up. So h is going to be negative, b was negative 8 over 2 times negative 1. It's going to be at 4. In order to figure out what's happening at 4, I could do it the way that I did it, but I have to put in a, b, and c. So even though c is 0, I still have to put that in if you want to use synthetic substitution. Negative 1, 4, 4, 16. So k is 16. Do I have enough to count up? Let's see, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 16 right there. If I go 1, 2, 3, 4, all the way up to 16, that would be the vertex. What were the last key points that we talked about finding in some of the different forms? What were the points that were best to find in factor form and in intercept form? The x-intercepts, yeah. So if I erase this really quick, I'd have to factor. So this would be now height is equal to, how can those two terms be factored? What's the first thing you look for when you try to factor any amount of terms? Now, before you even get to that, greatest common factor. Do those two terms have a common factor? Yes, they do. They both have a t. So just to help myself out, not only am I going to take out the t, because I have a negative in front. Not that you have to, you can get away without it, but I'm going to actually bring out a negative t. And if I bring out a negative t, that leaves me then t minus 8. So now when I split these, this is going to touch the x-axis when 0 is equal to negative t, and when 0 is equal to t minus 8. On this one, when I multiply by negative 1, what's negative 1 times 0? 0. So this is telling you that when no time passed by, the ball was on the ground. Which makes sense. We already knew that. The y-intercept was 0. But the second one that tells you when I add 8, that the second time the ball hits the ground is after 8 seconds. So, if you wanted to find any other points, you could. I mean, you could use transformations, you could substitute. But the point is that it looks like I already have everything I need. That's the path the ball takes. What was the maximum height of the ball? How high did the ball get? Yeah, did it give you a unit? It was meters. Yeah, it says up here meters. So the ball got to 16 meters. Now, because I don't see this question here, but there's a question that gets asked a lot when they ask how long did the ball take? See, it's about to ask you how long, but if they ask you how long did the ball take to reach its maximum height, what would you say? When the ball got up here to 16, how long had it taken?
4 seconds.
4 seconds, yeah, 4 seconds. But then now they want to know how long the ball is in the air. So from the time it was launched to the time it came back, how much time passed? Yeah, this one's 8 seconds. 8 seconds. Is that all there is on the first page? Oh, okay, cool. I have it here. This is what you have next, a rocket. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The height above the surface of the lake is given. So they've already modeled this for you. They want to know what is the height of the rocket after 1.5 seconds. Well, what does the H stand for? Height. What does the T stand for? Is 1.5 a time or a height? It's a time. So what most kids would do is they would get this 1.5 and they would plug it in for both T's. But if you want to be cool like me, I showed you an easier way of substitution. So let's do it my way. 1.5, negative 16, 64, and 80. I want to see what's going to end up here. Drop down to negative 16. Just use the calculator. Negative 16 times 1.5 should be negative 24, I believe. Check my math. I'm just doing it in my head, which is 40 times 1.5 is 60. So this is going to be 140. I got 140. You know if anybody disagrees. And height is being measured in feet, so 140 feet. If you don't understand what I did and you feel like plugging in the 1.5 and doing order of operations, you have my blessing. I have no problem with that. Okay. What is the maximum height of the rocket? So when we talk about maximum, what do you think we're looking for? The vertex. But which specific number from the vertex? I want a K, because H is just going to be the time. So when I do H is negative B, so negative 64 over 2 times negative 16, which is going to end up giving me 2. That 2 is a time. I know it's going to end up, if they end up asking me how many seconds does it take to get to its highest point, it's going to take, is it in seconds, right? It's got to be seconds. Height above surface. Yeah, I guess it's in seconds. So it's going to take 2 seconds to reach its height. It's a maximum height. But if you want to know what that height is, I got to plug in a 2. So I'll do the same thing I just did. 2, negative 16, 64, and 80. Negative 16, negative 32, 32, 64, 144. So it looks like on the last question, with a 1.5, it was right before it was about to get to its highest point. How long will it take for the rocket to hit 128 feet? This is also going to involve substitution, but 128, is it a height or is it a time? It's a height, so that needs to be where the height goes, where the H is. I'm going to plug it in for H. So I'll put 128 is equal to negative 16t squared plus 64t plus 80. Where in the first semester you learned several methods for solving quadratic equations. This needs to be solved for t, and you need to solve for the variable that's being squared. But the two most common methods require the same first step, which is to make the equation equal to 0. So I would say 0 equals negative 16t squared plus 64t, and then minus 48. Anybody remember what those two most common methods are for solving quadratic equations? What are the two most common methods for solving quadratic equations? Quadratic formula, which you could use that right now if you wanted. You have to make it equal to 0 first, but A would be negative 16, B would be 64, and C would be negative 48. Give you some big numbers, but it'll work. Or what was the other common method? It starts with an F and ends with factoring. Problem with factoring is factoring only works if your solutions are rational. It also requires a pretty good knowledge of the times tables. If you're not good with your times tables, you're not going to be good with factoring. I like to live dangerously, so I'm going to use factoring. But if you know how to use, remember quadratic formula? X equals negative b plus or minus the square root of b squared over minus 4ac over 2a. Facts. I'm going to first factor out a negative 16, like I did with the last one. If I factor out a negative 16, that gives me t squared. Then 64 divided by negative 16 is negative 4t. And then negative 48 divided by negative 16 is positive 3. Can you think of two numbers that multiply to give you 3 and add up to negative 4? 1 and 3. 1 and 3. No, well, negative 1 and negative 3. So negative 16, t minus 1. The negative 16 doesn't have a variable, so as far as the solution goes, that's irrelevant. It doesn't do anything. But t minus 1 can be 0 and t minus 3 can be 0. So I end up with, sorry that I'm running out of space, but you should see that t equals 1 and t equals 3. Now remember, let's keep this in context. You're like, oh wait, what does that mean? Are those the x-intercepts? I don't get it. No. The only reason I was able to get 1 and 3 is because I plugged in on 128. So how can I take those answers into context? What happened at 1 second and then at 3 seconds? The height is at 128, sure. This rocket went up, it hit 128, probably it went up a little bit higher. How high did it end up going? 144. Then it came back down and crossed through 128 again at 3 seconds, and then it finally went back down to the lake. But it just happened to pass by the 128-foot height at the 1 second mark and at the 3 second mark. After how many seconds after it was, that sounds weird. After how many seconds after it is launched will the rocket hit the lake? Well, there's a couple ways you can do this. We can go back up to the original, like we did with the last one, and then find the x-intercepts. Because when something hits the lake, how high is it off the ground? 0. Yeah. So you can put 0 equals negative 16 t squared plus 64 t plus 80. So you can do that and solve that, or you could take advantage of the symmetry. Actually, you know what? You're gonna have to do it that way. You can't take advantage of the symmetry. I take it back because it wasn't launched from the ground. It was launched 80 feet up. See, on the last one, if you noticed, from the time it was on the ground to the time it reached its highest mark, how long did it take on the last one that we did? No, from the time it reached the maximum, 4. But then on the way back, so from the high to the low, what did it take? It also took 4 seconds because the parabola is symmetrical. But on the first problem, the projectile was launched from the same height. It was launched from the ground. This one here is not being launched from the ground. It's being launched 80 feet up. So actually here I have to do it by factoring. Because like if you look at a parabola, it's not being launched from down here, it's being launched here. So if I use symmetry, it's just going to give me the point on the other side where it's symmetrical. It's not going to give me the ground. What should end up happening is that when I solve this, I should end up getting a negative, which even though you would love to have a time machine, since we don't have a time machine, really, since we're launching it from up here, the only way to get back to the ground would be to go back in time almost and get back to where it was launched. It's like it's not possible. You'll see what I mean. We should end up getting one positive time and one negative. I can still factor out. You can do quadratic formula if you want. You look like you want me to write. You want me to write down quadratic formula for you again? Do you remember quadratic formula? You don't remember it? This x equals negative b plus or minus the square root of b squared minus 4 over. Now, do you remember it from before the winter break? You can use that if you want, or I'm going to use factoring because it's quicker. T squared minus 4t minus 5. Can you think of two numbers that multiply to give you negative 5 and add up to negative 4? Negative 5 and positive 4. So 0 equals 16, t minus 5, t plus 1. This negative 16 is irrelevant. It doesn't do anything. It doesn't have a variable. But t minus 5 can be 0, and t plus 1 can be 0. So the time equals 5, or the time equals negative 1. So again, I'll ask you, does anybody here own a time machine? So this is saying if you want to reach the ground, you have two options. You can either go back in time 1 second. Sadly, we don't have the ability to do that. Or you can say it's going to take 5 seconds, which that makes 5 segundos. Any questions? If you have questions, ask now. Okay, let's do this next one. The nice one here, the nice thing about this one is they already give you the graph. You don't have to graph it yourself. Caleb, you staying with us? This is the next one, right? Because I had to piece this thing. That is the next one. A ball is thrown from the ground, represented by the graph below. What is the maximum height of the ball? Okay, just look at the graph. How high does the ball get? 2,000 centimeters. We're measuring in centimeters. So this would be 2,000. After how many seconds does the ball hit the maximum height? How long does it take to reach the vertex? 2 seconds. How many seconds is the ball in the air? Okay, so by the time it was launched, how long did it take from the launch for it to land? 4 seconds. And in which direction is the ball moving at 3 seconds? So if we look at 3 seconds, and this is the path of the ball, where is the ball? Where is it headed? Yeah, at 3 seconds, it's already coming back down. Gravity has already taken effect. Philip is standing on a rock ledge 64 feet above a lake. So this is going to be kind of like the one we did with the hill. Notice how it's being launched from above, but they've already given you a graph. They've also given you a table. And he tosses a rock with a velocity of 48 feet per second. The graph and table represent blah, blah, blah. So they've given you all the information you need. Let's see if we can answer the questions. What is the maximum height of the ball? Can you see that from the printout? How high did the rock get? It's being measured in feet. Yep, it looks like it's 100 feet. I agree. After how many seconds does the rock change direction in the air? That's a good way of wording it, because whatever goes up must come down, right? So it's going up, going up, going up. What do we call a change of direction? Also known as a vertex. But now they don't want to know how high the vertex is. They want to know how long it takes. So how many seconds did it take to reach the vertex? 1.5. It looks like 1.5. Yeah, it's between 1 and the 2. Should be 1.5. 1.5 seconds. Can you estimate the maximum height from the table? From the table? Yeah, I guess you can estimate it. I mean, a little bit of a tricky question because, I mean, it depends on how accurate they want us to be. So see, like when you look at the table, you see how this is at 96 and then at 96 again, and the same thing with 64 and 64. So you could assume then that it's going to reach its highest point somewhere in between there. So yeah, what we could definitely estimate is the time it takes. We know it's going to take a second and a half. Like what they're saying is if I couldn't look at the picture, if I only had a table, you know, can I estimate the vertex? Well, definitely the time. Well, what time is in between 1 and 2 seconds? 1.5. Now the height would be, I guess, a little bit trickier, but okay. So I guess you could say, look, at 0 seconds, it started off at 64, and then it went up. What is that? From 64 to 32. So as you go up, you also start to slow down because gravity starts to take effect. So it probably wouldn't jump up another 32. What's 96 plus 32? What's 96 plus 32? Yeah, 128. So we know it won't reach 128, but how high it reaches? Now, to be clear, this could be done. There's something called a quadratic regression that you can do and find exactly where it is. But we haven't learned that. I mean, I would fall more on the side of saying, yeah, you can estimate, but look, I mean, look at where the height ended up being. The height ended up being 100. Would you have any idea that it was going to be 100? Maybe get it close, but you understand? In order to find the equation of a line, how many points do you need? No. 2. For the equation of a line, 2 points. Find the slope, find the y-intercept. To find the equation of a parabola, you only need 3. Do they give us 3 points? Yeah, sure, we have plenty. So just to be clear, there is a way to find how high it gets, but that's not really what the question is asking. I have a feeling whoever wrote this wanted to put the answer as yes, but I don't necessarily agree with that. Because to me saying, oh, even if I were to estimate, yeah, it's going to be around like 116, 118. To me, that's not close enough. When does the rock hit the surface of the lake? What is the point on the graph called? And can you identify this from the table? Okay. So that's 3 questions in one. When? So this is the time. When does the rock hit the lake again? Or actually, it only hit it once because it was launched from a height. How long did it take to hit the lake? 4 seconds. What is that called on a graph? What's happening here at 4 seconds? What do you call that? X-intercept. It's called the x-intercept. And then the last question, if they didn't give me a graph and they only gave me a table, could I identify that? Yeah, sure, because it's the value of the time when the height is 0. Yes, that would be a yes. I would say yes. Okay, what is the domain in this scenario? Domain means what are all the possible x's? In this case, the x-axis is measuring time. So can you go backwards in time? So what's the first time that we're starting to measure? 0, and 0 is included. We are going to include 0. So that will be with a bracket, comma. How long is the projectile in the air? 4 seconds. Bracket. 0 and 4. You can also write it this way: 0 less than or equal to time less than or equal to 4. You can write that. Identify the vertex and the axis of symmetry. What do these represent in our story? Okay, so the vertex we had already mentioned. What was the vertex? 1.5, comma 100. If that's the vertex, what's the equation of the axis of symmetry? X is equal to 1.5. What do these represent in our story? Well, I wouldn't even know what to tell you about the axis of symmetry, but we know that the vertex is the maximum height of the rock. If the rock would have been launched from the ground, then you could have also said that the vertex is the halfway point of its travel. But 1.5 is not in the middle of 0 and 4. At 1 second, what direction is the rock moving? And at 2 seconds, what direction is it moving? So at 1 second, which is here, is it going up or down? It's still going up. At 2 seconds, is it going up or down? Down. So at 1 second, it's up. At 2 seconds. Ooh, Philip is standing on a rock ledge 64 feet of the lake. He tosses the rock with his velocity. Using, this is like subnotation. Using the height dependent on time is negative 16 t plus the initial velocity times time plus the initial height. Write an equation in standard form for the path of this is just substitution. See how they tell you this, like that notation, v sub 0 really just means initial velocity, but since they give you, like, when you rewrite it, t is equal, write everything up to here the same. Instead of writing v sub 0, write 48t plus the initial height, which they give you up here. So what goes there? 64. And they want it in standard form, so there you go. It's already done. Standard form. What's A in standard form here? Negative 16. What's B? 48. What's C? If you understand the concepts of like the characteristics of a parabola, on all of these problems where you have a projectile that's going up and then coming down, what do you think all of those functions should have in common? Very good. A is negative because they're all going to be facing down. Oh, is this the same one? Oh, well, sorry, I got it cut off. Oops. Okay, so this is the same one that we were just working on. I just made a mistake and cut it in 2 pages. So let me write that again then. I can just copy and paste. Let's do that. Copy. Oh, Martha just answered the question for us. Is this going to open up or down? Down. Why down? Because A is negative. Will the vertex be a maximum or a minimum? Maximum, sure. Why? Because the parabola is facing down. That's what you would write. On a downward facing parabola, the vertex is a max. Using your standard form from number 7, write the equation in vertex form. Decimals are okay. Okay. So let me just do this up here. H is going to be negative b, so negative 48 over 2 times negative 16, which is negative 48 over negative 32, which gives us 3 over 2. I don't like to use decimals, so you can put 1.5 if you want. We already have A, so we know this is going to be H. We already know that A is negative 16, so now we just need K. So 3 over 2, negative 16, 48, and 64. Drop the negative 16 times 3 over 2 is negative 24. That's 24. Times 3 over 2, 12, 36. And that's going to be 100. So this answer here, the h of t is equal to negative 16. X minus, or no, not x, it was t, the variable. T minus 3 over 2 squared plus 100. Same equation in vertex form. Using the equation from number 9, what is the maximum height the rock reaches above the surface of the lake? How did you get this answer? Okay, well, we already know this. How high did it get from the lake? 100. Not because of the last speech, but I'm taking it as that's what K is. Using the equation from 9, how many seconds? Okay. How long did it take to reach 100 feet? Yeah, 1.5, because that's what 3 over 2 is. This 3 divided by 2 is 1.5. Is this the exact same? I feel like, did I just copy this? Did we just do the same problem twice? Was their equation exactly? Oh, what it was is that okay, that's what it is. That they didn't give you the equation. They just gave you the graph, and then we came up with it. We came up with the equation on our own. But it's the same exact thing. So we already answered these questions. At 1 second, it's going up. At 2 seconds, it's going down. Let's go on to the next one. Frog. A frog is about to hop from a bank of a creek. The path of the jump can be modeled. They've already modeled it for us. That's important. Where h of x is, notice how a is negative. A fly is cruising at a height of 5 feet above the water. Can the frog catch the fly without jumping? So a frog is about to jump. The path of the jump can be modeled. Where the frog's height above water, and x is the number of seconds since the frog jumped. So I guess we're not. Can the frog catch the fly without jumping? Huh? Well, good. Like, so this is not like it's like sticking his tongue out or anything, right? He's about to hop. He's about to hop. The path of the jump can be modeled. So that's the path of the jump. Where a fly is cruising. I don't know. Let's ignore 14. Let's just graph this. So, okay, where is that going to cross the y-axis? At 1. We can calculate which is number 15. So negative 4 over 2 times negative 1 is 2. And then the k is going to be plug in a 2, negative 1, 4, 1. So negative 1, negative 2, 2, 4, 5. So 2 and 5. 2 and 5 is going to be then We can even use the axis of symmetry since the vertex, this is the axis of symmetry. I know I can put a point there because that's symmetrical with the y. Something else I can do. But then if I want to see how long it's going to take to hit the ground, I don't know if they're going to ask me that later, I would need to factor. So if I factor out a 1 here, are they going to ask me that? Vertex. Doesn't look like it's going to ask. Does it ask me later on? Okay, so if I wanted to find this here, I would factor, but it doesn't look like it's going to ask me. And even if it did, I wouldn't be able to, because there's no two numbers that multiply to give you -1 and add up to 4. At least not a that part right. 2 -1 4. So I was trying to figure out where it was going to touch the x-axis, but it's not going to be a whole number, and it doesn't look like they're even going to ask it. So let's just answer the questions. What is the extreme value of a maximum or minimum? How high does the frog get? When they don't tell you like the x or the y, if they use maximum or minimum, they're talking about the y. They're talking about the k. So how high did it get? Oh, actually, no, I'm sorry. I read it wrong. It's saying, is it a maximum or minimum? Okay, it's not asking what is the value. It's just asking, is it a max or a min? Yeah, it's a max. It's a maximum. It went up and then down. What is the vertex of the equation? That's what we just found. It's going to be at 2, 5. And if the frog jumps to catch it with his mouth and not the tongue, would he be able to catch the fly? That's what I thought they were asking at 14. I don't even know what 14 is asking. This is what I thought they would ask. So if he's not going to use the tongue to stretch out any further and just try to gulp it, is it able to gulp it if it's at 5 feet high? Well, was the frog able to reach 5 feet high? The fly's at 5 feet. Was the frog able to reach 5 feet? Yeah. Yes. And then graph the path of the frog and the fly. Well, I actually just did that. The parabola is the frog and the fly is just horizontal, hanging out at 5 feet. See if we can do one more before the ball. No more rockets. Let's see this one here. The shot put. What is the maximum height of the shot put? How high did it get?
5 meters.
5 meters. After how many seconds is the shot put at the maximum height? 1 second. At 0.5 seconds, what direction is it moving? Yeah, it's over here at 0.5, it's still going up. How many seconds is the shot put in the air? Ooh, this is a good one. The dimensions of a rectangle were given by x plus 3 and x plus 4. The area of the rectangle is 72. What are the dimensions of the rectangle? You might have seen this earlier. What's the formula for area of a rectangle? Length times width. So they give you the area 72, x plus 3, and x plus 4. So we need to find the dimensions. First thing you got to do is FOIL here. So x squared plus 4x plus 3x plus 12. And once you go minus 72 on both sides, you get 0 equals x squared plus 7x minus 60. I just combine like terms. 4x and 3x is 7x. 12 minus 72 is negative 60. Can you think of two numbers that multiply to give you negative 60 and add up to 7? Yeah, negative 5 and 12. So I can say x minus minus 5 and x plus 12. But if you can't come up with that, what's something else you could have done there? If you struggle to come up with that, what's something else you could have done? Quadratic formula. What I wrote on the board before. Negative b plus or minus. Now here I can just say x minus 5 is equal to 0, x plus 12 is equal to 0, so I get x can be 5 and x can be negative 12, but this is a word problem. You got to keep it to context. Yes, I did everything correctly, but these are distances. And yeah, look, that doesn't mean that anything is going to be like 5 inches or 5 feet long or anything, but it means that I'm supposed to get these numbers and plug them back in for x's. And if I plug in a negative 12, I'm going to get a negative dimension. You can't have a negative dimension. So the only one that works here is 5. So what are the dimensions of the rectangle? Well, then x plus 3 would be 5 plus 3, which is 8. 5 plus 4 is 9. What are the dimensions? It's an 8 by 9 rectangle. Give you units. Meters. 8 meters by 9 meters. Okay, look, this one I can at least start with. The width of a rectangle is 1 meter less than its length. Find the area of the rectangle. The area is 42. What are the dimensions? So the area here is still length times width, but the difference is they tell you that the width is 1 meter less than the length. So you could take out the width and put length minus 1. So 42 is equal to length times length minus 1. If I distribute here, I get 42 is equal to length squared minus length. Once I do minus 42, 0 is equal to length squared minus length minus 42. Can you think of two numbers that multiply to give you negative 42 and add up to negative 1? Negative 7 and positive 6. So 0 is equal to length minus 7, length plus 6. So length minus 7 equals 0, length plus 6 equals 0. Length can be 7 and a length. Have you ever seen a rectangle that's negative 6, whatever, meters? Yeah, meters long. Have you ever seen a rectangle that's negative 6 meters long? No. So the length has to be 7 meters. So then how long is the width? 6 meters. 7 minus 1. We have the practice test tomorrow. You can also start working on your Khan Academy already. If you have any issues signing in, let me know. Come in the morning, we can figure it out. Yeah.